Next preparation method, third preparation method. From carbonyl compounds. Carbonyl compounds. Preparation of alcohols from carbonyl compounds. Roman number 1 is our means preparation from alkyl halides. Roman number 2 preparation from alkenes. Roman number 3 preparation from carbonyl compounds. See, by using reduction, by doing reduction of carbonyl compounds, we will get alcohols. Clear? Now I am giving reducing agents. Within the bracket you can write a reduction by reduction. By reduction. So to carry reduction we need some reducing agents. First reducing agent, lithium aluminium hydride. It is abbreviated as LiAlH4 or LAH. Both are same. Lithium aluminium hydride, also abbreviated as LiAlH4 or LAH. Both are same. And second reducing agent, sodium borohydride. NaBH4. Sodium borohydride, NaBH4. Very important reducing agents in the organic chemistry. Okay. And another reducing agent also there, sodium in E2H, sodium in ethanol. These three are the reducing agents which are used to reduce carbonyl compounds to alcohols. Reduction, all are same terms. Adding hydrogen. Right. Now let us know some points about the lithium aluminium hydride. Lithium aluminium reducing agent. Clear? Shall I go to next page? Have you noted this? Now keep heading. Lithium aluminium hydride, LiAlH4. See, lithium aluminium hydride is a powerful reducing agent. It is a versatile reducing agent, non-selective reducing agent. It reduces majority of the functional groups to alcohols. That's why it is called as versatile. Versatile means if it reduces most of the functional groups, it is called as versatile reducing agent. Clear? Non-selective. Non-selective means, see, here carboxylic acid is there, here aldehyde is there, here ketone is there. This reagent reduces all functional groups. Okay, non-selective, it won't reduce selectively one functional group. It reduces all the functional groups. So non-selective. Are you getting the point? There are carboxylic acid is there, aldehyde and carbonyl is there. Three functional groups are there. But this reagent reduces all, won't reduce particularly, selectively. So it is a non-selective reducing agent. I'll give you that examples also, you can understand easily. Clear? So powerful reducing agent, non-selective reducing agent, versatile reducing agent. See the points? It is a powerful reducing agent. RA stands for reducing agent. It is a powerful reducing agent. It is versatile. It is versatile reducing agent. It is non-selective. It is non-selective reducing agent. Non-selective reducing. See, What is the use of knowing all these points? See, if you know additional information about the reagent, then you can understand the reactions easily. If you have additional data, you can do the questions easily. That's why I'm giving. Unnecessarily, I won't give. Clear? Unnecessary information, I won't give. All these points will help you. Okay? Now, let us see. What is the versatility? Look at this. Aldehyde, ketone, carboxylic acid, ester, acid halide. See, these many functional groups, not only single functional group, all these functional groups when treated with lithium aluminum hydride, very important. You learn about each and every reaction, each and every functional group. Clear? Will convert it to alcohols. That's why it is called as versatile reducing agent. Versatile reducing agent. It reduces majority of the functional groups to alcohols. That's why it is called versatile. Clear? Aldehyde to alcohol, ketone to alcohol, ester to alcohol. Again I wrote ester 2 times here, sorry. Acid. Okay, acid to alcohol, acid halide to alcohol. Clear? Okay. This is the meaning of versatility. Okay. Right. And once all of you look at this, lithium aluminum hydride is a, tell me everybody, powerful reducing agent. Versatile and non-selective. Non-selective means, once go back to this, just a second, sorry. Non-selective means, see, you have these many functional groups. It reduces all these functional groups to alcohol. Okay, won't select particularly one functional group. Clear? It reduces all. If other reagent is present, then that reagent select particularly one functional group only. Best example, sodium borohydride. NaBH4 reduces only aldehyde and ketone. NaBH4 reduces only aldehyde and ketone. So sodium borohydride, see, another reagent is there now here. This is a selective reducing agent. It won't reduces all. Selectively reduces aldehydes and ketones only. Clear? That is the meaning of non-selective. Okay? Right. That is about lithium aluminum hydride. Next, right, sodium borohydride. About sodium borohydride. Sodium borohydride. Sodium borohydride. NaBH4. NaBH4. Sodium borohydride. Write the points. It is powerful reducing agent. Which is powerful reducing agent? Lithium aluminum hydride is a powerful, strong reducing agent. This is poor reducing agent or weak reducing agent. RA stands for reducing agent. Okay. It is a selective reducing agent. It is a selective reducing agent. It is not versatile. It is not versatile. It is not versatile reducing agent. Weak or poor reducing agent, selective reducing agent, not a versatile. LiAlH4 is non-selective. It is selective. Why it is selective? Selectively it reduces aldehydes and ketones only. Clear? If you have information about the reagents, then you can understand the reaction easily. Clear, all of you? Right. If you don't know these points, you face some difficulty in doing the questions. That's why better to learn. Right. Look at this. I am writing only two. What are the two? Aldehydes and the ketones only. it won't reduce other functional group. It is not having power or caliber or capacity to reduce other functional groups. Okay, right, that is about the reducing agents, lithium aluminum hydride and the sodium borohydride. And sodium in ethanol, there is no importance to learn about this. Okay, just you remember sodium in ethanol also used to reduce carbonyl compounds to alcohols. Just you remember, we will discuss one reaction directly, one example directly. Right. Let us start the examples. How carbonyl compound will convert it to alcohol. I'll give you simple trick. Actually, we don't go with original mechanism, but that will give you confusion. Okay, I'll give you shortcut methods. If you remember the shortcut methods, then you can understand easily. Reduction by using reduction of carbonyls. We are doing from carbonyl compounds only. Clear? Reduction by using LaH, lithium aluminum hydride, or NaBH4 or sodium in ethanol. 3. We can use lithium aluminum hydride, we can use sodium borohydride, we can use sodium in ethanol. See the simple trick, all of you stop writing. If you write, just stop and look at the board. Lithium aluminum hydride, or sodium borohydride. All of you stop writing. If you write, please stop and observe. First you should know the shortcut trick. This reagent or this reagent, or even sodium in ethanol, you can write here sodium in ethanol. Okay, see, add hydrogen, one hydrogen to oxygen, another hydrogen to carbon, and break the double bond. You know already during addition, double bond will convert it to single bond. H, and double bond will convert it to single bond. Clear? R, C, O, H, and here one H. Here already H is present. Clear? Now R, CH2OH. This can be written like this: R, CH2OH. Alcohol is produced or not? This is not original mechanism. Original mechanism will give you confusion. Shortcut mechanism only, very easy. Follow this one only. Okay, right. Any doubt in this? Did you get this shortcut mechanism, all of you? Right, clear? Very easy. Add hydrogen to oxygen and hydrogen to carbon, right, and remove the double bond. Alcohol will be produced. This is aldehyde. Do same for ketone also. See, I am taking ketone here. Lithium aluminum hydride, sodium borohydride. Same. Shortcut mechanism is same for aldehyde or ketone. Add hydrogen to oxygen, hydrogen to carbon. Remove double bond. R, C, O, H. Here H. Here R. Alcohol. 2-degree alcohol is produced. Simple mechanism. Do the same shortcut for sodium in ethanol also, but sodium in ethanol is having some special name, that is Boult-Blanc reduction. I'll give you that separately. Clear? After completing these two, we'll go with the sodium in ethanol, but method is same. Okay, adding H, but name will change. Boult-Blanc reduction, that is. Right, copy this, copy. Shall we go to next page? Right. Now let us take the examples. Right. What is its name? Anybody? What is its name? What is its name? Ethanol, ethanol are also called acetaldehyde. Ethanol or acetaldehyde. Ethanol are also called as acetaldehyde. See, this is a reducing agent, LiAlH4 or NaBH4. Ethyl alcohol, ethanol. See, ol stands for alcohol. Ethanol to ethanol. You know already shortcut mechanism. What is the shortcut mechanism? Expand this. CH3CH4 can be written like this. CHO can be written C double bond OH. Aldehyde can be expanded like this. Okay. Now, when we use LiAlH4, what happens? Hydrogens, 2 hydrogen atoms will be added. 1 hydrogen, 2 oxygen, and hydrogen 2 carbon to give CH3 COH. Here H, CH3 CH2OH, CH3 CH2OH. This only. Both are same only. Ethanol. Clear, all of you? Everyone? Shall I go to next example? Shall I go? Can you say the name of the product? Anybody? Can you say the name of the product? What is the name of the product? Correct IUPAC name of the product? What is its name? Give the number. 1, 2, 3. 2-propanol. 2-propanol. Same. Here only I am giving the mechanism. H2 oxygen, H2 carbon. Correct only now? Did you get this? Similar to previous mechanism. Any doubt in this? All of you? Let us take another example, one more example. Example 3. Cyclohexanone. What is its name? Cyclohexanone. When treated with lithium aluminum hydride or sodium borohydride. Don't forget, with sodium borohydride also mechanism is same. You can write here NaBH4. NaBH4. Here also you can write NaBH4. Sodium borohydride. Mechanism is same. Can you guess the product name? Anybody? What is the? Yes, cyclohexanol. How will you get cyclohexanol? Look at this, all of you. One H2 oxygen, another H2 carbon. See, like this. Here you no need to see. Here I am adding H, but here I am not representing like this. You no need to represent. If you represent or do not represent, nothing will happen. Hydrogen will be present there only. Every time you no need to represent like that. Cyclohexanol. Clear? So shortcut mechanism is very easy. Follow this shortcut mechanism. Right. Let us go to next method. Next example. In this, tell me, in this how many functional groups are present? Say the name of that functional groups. One functional group or two functional groups or three. How many functional groups are present, and give names. Mention the names. What are the functional groups present in this compound? Tell me. Yeah, aldehyde and ketone, both. See, terminal C double bond OH represent aldehyde. Aldehyde can be written like this. Look at this, all of you. CHO can be written like this. If you observe this unit, C double bond OH, that will be aldehyde, and this is ketone. Lithium aluminum hydride is a powerful reducing agent, versatile reducing agent, reduces all types of functional groups. Both are reduced. Mechanism is same. Shortcut mechanism. H and H. Clear? Next, H. OH. Here you no need to represent hydrogen. Now see, another side chain also there. Here one H is there, right? And you are adding one new H. Why I am writing H here? Because to write like this. CH2OH, both are same. See, this carbon here, dot is there, na? Dot carbon is having how many hydrogens? 2. So CH2OH. Okay, already one H is linked, another H is coming. See, two hydrogens, and one OH, this OH. Clear? To this carbon means this one. Two hydrogens are attached. One hydrogen is already attached, one new hydrogen is coming. That's why I wrote two hydrogens here. So one carbon with two hydrogens, CH2OH. Clear? Is it okay for everybody? Got it, all of you? Right. Next method, reduction of esters. This is very important, like carbonyl compounds. See, from carbonyl compounds we have seen lithium aluminum reagents. From carbonyl compounds we have seen, right? By using these reagents. From esters. From esters. Listen carefully. Here also we use reduction methods only. Reduction methods. From carbonyl compounds also we prepared by using some reducing agents, right? Lithium aluminum hydride, sodium borohydride, sodium in ethanol. That is a Boult-Blanc reduction. I will give you wait for some time. From esters. From esters also we can prepare alcohols by using particular reducing agents. Here also we have some specific type of reducing agents. One is already well known, LiAlH1, lithium aluminum hydride. Second one is DiBAlH, DiBAlH, DiBAlH. DiBAlH, abbreviation is diisobutyl aluminum hydride. You should know the names also, okay? Diisobutyl aluminum hydride. Once look at this, all of you. You know about lithium aluminum hydride. This is isobutyl group. This is another isobutyl group. See, I'll tell you why it is called isobutyl. See, 1, 2, 3, 4. Okay, iso group, 1 carbon with 2 methyls, isobutyl. Here also 1, 2, 3, 4. Isobutyl, 4 carbons are there, iso group is there, isobutyl. This is one isobutyl, this is one isobutyl. So diisobutyl. In the middle, aluminum is present. Aluminum hydride H. Why I am giving the structure? Sometimes you will get the structure also. Clear? Generally abbreviated as DiBAlH, most important reagent. DiBAlH, diisobutyl aluminum hydride, used to reduce esters, particularly used to reduce esters. Lithium aluminum hydride can reduce esters to alcohols. DiBAlH can reduce esters to alcohols, but sodium borohydride do not reduce esters because it is a weak reducing agent. I already mentioned selective reducing agent, poor reducing agent, weak reducing agent. So sodium borohydride do not reduce esters. Here our heading is esters. Very important point, valid point. Sodium borohydride do not used to reduce esters to alcohols. Clear? Right. Let us start examples with lithium aluminum hydride. First with the lithium aluminum hydride. Reduction with the lithium aluminum hydride. Lithium aluminum hydride. What is ester? RC double bond O R. Here you can take R or R dash, super wish. This R may be same or may not be same. Okay, sometimes both are same, sometimes both are different. Here also I'll give you one shortcut trick to write the product. See all of you, but here the shortcut is little bit confusion, but if you practice then you will get. That is easy only. See, first you have to add hydrogen to oxygen. 2 hydrogens to carbon. In the previous reaction, we added only 1 hydrogen to carbon. 2 hydrogens to carbon. Again, hydrogen to oxygen. For oxygen, 1 hydrogen. For oxygen, 1 hydrogen only. But for carbon, 2 hydrogens. Okay. And simultaneously, you have to break the bond. Simultaneously, you have to break the bond. Very, very important. Once again, add 1 hydrogen to oxygen, 2 hydrogens to carbon, break a carbon-oxygen single bond, break a carbon-oxygen single bond. Let us write the product. We'll take some examples, then you will get see. R, C, O, H. Here how many hydrogens we are adding? 2. RCH2OH, RCH2OH plus ROH. 2 different alcohols will be produced. 2 types of alcohols are produced. You are preparing alcohols. From esters you will get 2 different types of alcohols. Very important. Clear? Are you getting, everybody? This shortcut mechanism is okay. Once you tell me, anybody please tell me what we have to do. Tell me, then I'll get. Yes, tell me. Yes, you write it. Better to write it, okay, within the brackets. Two hydrogens to carbon. 2 hydrogens to carbon. Third one, break carbon oxygen single bond. Carbon oxygen single bond. Let us take one example. Or better to take simple ester, then I can you give its name? Can you give the name of this ester, anybody? Can you give the name of this ester, anybody? What is its name? You know already nomenclature. Can you give its name? What is the name of the esters format? No, that is for ethers. That is for ethers. For esters, alkyl alkanoate, methyl ethanoate. Here 2 carbons are there, now 1, 2. Okay, once watch esters nomenclature. Methyl ethanoate. First we are using lithium aluminum hydride. Follow the shortcut mechanism. Hydrogen to oxygen, and 2 hydrogens to carbon, and break a carbon oxygen single bond. Right. then product is CH3. See, this carbon is getting 2 hydrogens and OH, carbon 2 hydrogens, so carbon 2 hydrogens and OH, carbon 2 hydrogens and OH, and this bond is going to break, so plus CH3OH. So you are getting ethanol and methanol, 2 alcohols are producing, clear everybody? Methyl ethanoate produce 2 types of alcohols. Next, you tell me, is this reaction possible? Is this reaction possible? Is this possible? Will we get the product? Will we get the alcohols here? Will we get? No. Why? Yeah, sodium borohydride is a weak reducing agent, no reaction. Very important point. I'll give you why I am giving this example. I'll give you some important examples to you. Wait for some time. Sodium borohydride is a poor reducing agent. It reduces only carbonyls, means aldehydes and ketones, to alcohols. Okay, right. Let us take some other examples. You write this also, and reason also. Just you write one sentence. It is a poor reducing agent. Do not reduce esters. It is a poor reducing agent. Do not reduce esters. Okay. Shall we go to next page? One cyclic example. Let us take one cyclic example. Here you have 2 functional groups, ester and carbonyl. I already told you lithium aluminum hydride is a powerful reducing agent, versatile reducing agent, reduces all types of functional groups. Clear? So you have to reduce ester and carbonyl. You know shortcuts for both. I given shortcut mechanisms for both. Okay, let us see. Hydrogen to oxygen, hydrogen to carbon. Next, hydrogen to oxygen, and this is ester part. In ester part, 2 hydrogens to carbon. Just now I given. Clear? Here hydrogen to oxygen, and simultaneously break carbon oxygen single bond. Break carbon oxygen single bond. Clear? Just I merged 2 different reactions. Clear? I didn't give any new reaction to you. I just merged ketones and ester. This is not new reaction. Within single molecule I given 2 functional groups. Write the product. OH. Here C, it is getting 2 hydrogens, so H2, and OH, and here bond is breaking, so don't write anything here, just leave it. This is one compound plus C, one line, another line OH. Okay, OH. Or you can write like this also. This is the CH3 CH2OH only, na? CH3 CH2OH. This compound is ethanol. CH3 CH2OH. This is the product. You will get these type of examples only. This complex examples only in the weekend exams. You won't get simple examples. You should do practice. Yesterday I given homework, only Meenakshi sent answers. Nobody sent answers. Only one girl sent answer. What about you? Remaining students, I don't know. If you do like this, then you have to face the problems. One student only responded and given answers to me. You wanted to see the same story? Weekend incomplete preparation, getting 90, 100 marks in every weekend exams, okay? If you want that, then do like that only. Otherwise, follow the instructions, do the homework on time. Right. Shall we go to next example? Is it okay for you, everybody? Did you get this? Surabhi? Surabhi, ఇది అర్థమైందా నీకు? Surabhi. ఓకేనా? ఐశ్వర్య, ఈ ఎగ్జాంపుల్ అర్థమైందా లేదా? ఐశ్వర్య, ఇంకా ఉబేద్ అండ్ సృజన్. సృజన్ ఫాలో అవుతున్నారా? Some other girls. Aisha, what about you? Are you following Aisha? Okay. If I forget anybody, Meenakshi is responding, Bhakti also responding. Right. Let us take one important example. Sodium borohydride. In the last example, I took lithium aluminum hydride. Here I am taking sodium borohydride. Yes, very good. This is ester. How to identify ester? See, C double bond O. If you observe this arrangement, carbonyl carbon and directly if carbonyl carbon directly connected to oxygen, this is called ester. Like this. This arrangement is called as ester. Some students will think that this is ketone. Ketone is present. That is wrong. Clear? C double bond O. Next to O is there ester. This is ester. Clear? And this is ketone. Ketone. Ester functional group. Clear? Right. See, sodium borohydride is a weak reducing agent that do not reduce ester. So ester will retain in the product. Okay, as it is. It will come as it is. It won't be disturbed. It won't reduce affected by the sodium borohydride. Clear? But sodium borohydride can reduce aldehyde and ketone. So ketone will be reduced. So I said there is no need to write hydrogen. Write ester as it is. Clear? Because sodium borohydride is a weak reducing agent. It reduces only aldehydes and ketones. Clear? All of you? See, this is ester, right? Ester. Ester is won't reduced by sodium borohydride. Why? Sodium borohydride is a weak reducing agent. It won't reduce ester. So ester will present as it is. It is unaffected by this reagent. But sodium borohydride can reduce ketone. You know already how to reduce ketone. add H2 oxygen, H2 carbon. So this part will change, means this will change to alcohol. This will retain in the product side. Is there any change in the ester? No. Why? Because NaBH4 is a weak reducing agent. Next, diol H. By using diol H. First, lithium aluminum hydride is over now. Next, by using diol H, diisobutyl aluminum hydride. You know the meaning of this symbol, everybody? Bhakti? What is the meaning for this? Very danger. Diol H example is most important. Esters are first keep heading by using diol H. By using diol H. On the arrow mark, you will get mostly this abbreviation diol H. Directly you get like this only, diol H. Writing the product is most easy. This is most important now, and writing the product is most easy. Very, very easy. Very simple. See how to write the product. Break carbon oxygen single bond. Break carbon oxygen single bond. Add hydrogen here and hydrogen here. Cut this. Okay. Now look at the product. R C double bond O, C double bond O H. Here you can write R, here you can write. Both are correct only. Plus ROH. Actually, this is our required product, right? Alcohol is our required product. ROH. Break carbon oxygen single bond and add 2 hydrogens. I'll give you one example, then you can understand easily. Break carbon oxygen single bond. Carbon oxygen single bond and hydrogen CH3 C double bond OH. Aldehyde is producing, consider aldehyde as a byproduct. C double bond OH. CH3 C double bond OH. We are breaking this bond, so plus CH3OH. Very, very important. Diol H cleavage is very, very important. Easy or not? This is easy only, na? Diol H cleavage. Any doubt in the cleavage of diol H? Meenakshi, follow Yava. No, not minor, major. Actually, you have to get alcohol now. So consider this reaction is the preparation of alcohol. Clear? In the next chapter, third chapter, you have to prepare aldehyde. There you highlight the aldehyde. In the next chapter, we have to prepare aldehyde. Then we highlight this. Here our aim is to prepare alcohol. So we highlight alcohol. Not major, minor, both will form. Okay, based on the required product, we will highlight that. Clear? Other students? Everybody? Okay, we'll continue tomorrow.